Thanks for joining me today and welcome to session 4 of Innovator Island, where we will be building a serverless web application for a theme park. These videos are consecutive, so if you've come to this video directly and haven't tried the other ones first, start at number 1 so you can build the infrastructure and work your way up to number 4. My name is James Bezic. I'm a developer advocate here in the AWS Serverless team. Prior to being a DA, I was a product manager and also a software engineer for quite a long time as well. The most important thing on this slide is my Twitter handle and my email address. So if you have any questions about this workshop or just serverless in general, feel free to reach out to me anytime and I'll do my very best to help. So the agenda today, we've got quite a lot to do. This is session 4 and this continues to build on the 3 previous sessions. So in day 1, we set up Cloud9 and the back end of the web application. We deployed the front end application with Amplify Console to a public URL. Then on session 2, we configured real-time messaging. And then on session 3, we then looked at photo compositing and chroma key using a back-end workflow using S3 buckets and Lambda functions. Today we're looking at analyzing visitor stats for tens of thousands of visitors who are coming to our theme park. Now the goal of this whole exercise is to learn how to use a range of different AWS services to build a real-time web application. All of the code is provided for you. You don't actually need to write any code at all to solve the challenges. And if you have any questions, feel free to raise them at any time by contacting us. So the theme park is now open in our scenario and thousands of people are pouring into the park and using the mobile app to discover all the rides and what they like about them. But the business behind the park has questions about the numbers. So the park visitors have wristbands and these collect data during their visit. The wristbands record the entry and exit time into the park and they keep track of each ride that the person visits along with ratings. So our challenge in this session is to collect all this data and find trends to business-related questions. So in terms of tools and services we're using, we're looking at Kinesis Data Firehose today, along with Quicksight, and also we'll be implementing a simulator to build all of this data. Now most of this session is going through the workshop and doing coding and discussing any important items as they come up. Don't forget, this is a video, so anytime I'm moving ahead of where you are, feel free to pause, and I'll always be there when you unpause the video. So let's just run through a few prerequisites that you need before getting started. First, you need an AWS account, and if you don't have one, you can sign up at aws.amazon.com. Please make sure that you're using one of the regions that are supported in the workshop. Those were specified in Module 1. Now once you select a region, it's really important you don't change the region from session to session, otherwise you'll get unexpected results. In terms of cost, this workshop is completely free. It doesn't cost anything to watch the videos, but you may incur small charges from running the steps in the videos, since some of the services that we're using today in particular are outside of the free tier. So make sure once you've gone through the workshop to run through the cleanup section as well. This will help reduce any unintended charges once you've finished learning from this series. Now to take part in today's activities, you will need a desktop computer or a laptop and not a tablet. Please use the Chrome or Firefox web browsers for optimal compatibility. We've tested the workshop against both of those browsers. We'll be using quite a few different AWS services to build our serverless application solution, so existing familiarity with the AWS Management Console is very helpful, but it's not essential. All of this continues from previous sessions, and our goal today is to help you complete this workshop. So let's take a look at this adventure. We're on day 4 of the 5-day series of all the different steps throughout the park. So every park guest has this wristband and it collects this information about the time they enter the park and leave the park and the rides they visit. And visitors also rate each experience they have by tapping a wristband on the ratings bar after they leave the ride. So in this section we're going to be looking at how we collect and aggregate all of this data with Amazon Quicksight. We have a number of important questions from our park bosses about park performance and operations. And so today we're going to use Quicksight to answer those questions and help keep improving our guest experience. So let's take a quick look at some of the AWS services that we'll be using. First of all, there's Cloud9. We've been using this in the last few sessions. This is the cloud-based IDE that lets you download all of the code, run a terminal, and just run all of everything we need to go through the workshop within a browser. Then there's Lambda. Lambda is our on-demand compute service that's the heart of the AWS Serverless portfolio. We've used it quite a lot this week, and we'll continue to use that today as well. S3 is as an object store in AWS. It offers 11 nines of durability, so it offers incredible durability for data, but it's also very powerful for serverless applications. And we saw a little bit of that in the previous session in terms of managing photos being uploaded by users. But in terms of processing streaming data, it also has an important role there, so we'll be discovering some of that too. Now, Quicksight is a business intelligence and visualization tool for large amounts of data. It's great for analyzing streaming data, for example. And we'll then be looking at Kinesis Data Firehose. For using this, we can load streaming data into data lakes, data stores, and analytics. Now, this is fully managed, serverless, and it scales automatically with no ongoing administration, so it really works well for our park scenario. Now, in terms of cost, this is based on the volume of data ingested, so it doesn't have any minimum fees or setup costs. It's purely related to the amount of data that you'll be processing. And critically today, it also lets you transform data serverlessly using Lambda. So we'll be seeing why that's really important for getting through some of our solutions today. So just going through the workflow of how this is going to be implemented. So we talked about these visitor wristbands that park visitors have. So those wristbands produce data every time they're tapped on something throughout the park, and they create a JSON payload that looks like this. So here's an example one, and it shows the ride ID, a rating from a visitor, the timestamp of when they were at the ride, the visitor ID, information about the visitor, their name, age, birthday, and so forth, and also where they came from to visit the park today. So a lot of different pieces of data that are logged every single time they tap one of these wristbands. So this is loaded into Kinesis Data Firehose continuously, and this produces batches of objects in S3. And you'll see in this screenshot we've got these 5 megabyte objects that are created, and essentially Kinesis Data Firehose is holding all this data until it gets to a certain amount of data, in this case 5 megabytes, and then writing that data to an S3 bucket. Finally, we can then use Quicksight to listen to one of these buckets and retrieve this data. And so a lot of the lesson today will be going through using Quicksight to create these visualizations that can make it really pretty easy to create business-friendly dashboards for understanding things. So we'll be going from the development-heavy JSON on the left all the way through to the business-friendly charts on the right. So in reality, we don't have a theme park, unfortunately, or any real visitors, but we do have a simulator. And so this is going to be running in the Lambda function, and I'll show you how we set this up. This will simulate the thousands of visitors going through the park, and it'll create a day's worth of data for us to play with. Okay, so let's get started. So everything today we'll be covering is in module 5, and that's in this link, s12d.com/island workshop. Okay, let's get started. Great, so first of all, go to the s12d.com/island workshop URL. That will take you to this instruction page, and then go to module 5, which is park stats. And that'll take us to this overview of what this module is about. So I'll do this as I've done in the previous sessions, where I'll put all the instructions on the left of the screen and put all of my work on the right using a split screen so you can see exactly what I'm doing. So the preamble here explains what we just talked about in terms of the wristband collecting data and recording data from those visitors. So we want to be able to process this data using a Kinesis Firehose delivery stream. And then we're going to set up a simulator and analyze this with Quicksight. So there's a few different things to do here to get through this module. How it works also explains some of this in a bit more detail in terms of how the message is structured and how it's ingested. And so the simulator will be deploying to create these messages, simulates this data from something like 50 to 70,000 visitors. It picks a random number, so it's usually a spread between that over the course of one 12-hour day to give us enough data that we can really get some interesting analytics from. So the serverless backend, you might recognize from a few minutes ago, looks like this. We're going from these visitor wristbands through to Kinesis Data Firehose to an S3 bucket onto Quicksight. And so the way this would work in practice is the wristbands would emit messages, and those would be sent into the AWS IoT infrastructure, and that then routed on to Kinesis Firehose. This aggregation then happens automatically and is put into the S3 bucket. So instead of having one message per object, you have one object containing many, many messages. And then really we just have to configure Quicksight to look at the right S3 bucket so it can pick up that data as it arrives. Now these environment variables we need to configure, but before we do, let's log into our AWS account. I've logged into mine here, and what we want to do is just start the Cloud9 instance that we've been using the last couple of days. So to do that, click on the services drop down or search for Cloud9 and just click on, I'm going to open this in a new tab, just click on Cloud9 there. You'll see any Cloud9 instances you have, and theme park development is the name of the Cloud9 instance we've been using. So click on Open IDE. This just takes a couple of minutes to start. So Cloud9 under the covers is using an EC2 instance, and when it goes into suspend mode, that's actually an EC2 instance that we're waking up, and it just takes about a minute to come back to life. But it'll remember all of the layout of everything that we've had so far in terms of the files that have been downloaded to the instance, and also the file editors and the terminal settings as well. Now, the reason we want to set up these environment variables, if you are running these sessions continuously one after the other and you have the terminal already open, the environment variables will already be known in that terminal. But if you're restarting like I am just now, generally this won't be remembered. You can configure this so that it will, like any Linux environment, but out of the box, if I look at this, for example, AWS region variable, it's been reset. So by copying all of these and pasting that in, we now have the environment variables that is useful for the deployment process. So if I echo that again, you'll see now I have the USD swan. Also, you want to make sure you're running in the same region that you've been running the previous sessions in. It's really important, otherwise you'll get results that are a little bit strange. So you can check that by just, from your AWS console, clicking the drop down in the top right. Okay, so we set up those environment variables. Let's take a look now at configuring this infrastructure. There are three subsections to the module: configuring the Kinesis Firehose, deploying and running the simulator, and configuring and using Quicksight. So let's get on with the first section. So in terms of configuring Kinesis Firehose, this is a fully managed service that loads streaming data into data lakes, and it's different to regular Kinesis. So this is completely serverless, and we don't need to manage shards or anything complicated. It's simply, once it's configured, we can throw practically any amount of data at this service and it will keep up with what we need. So the scaling that's automatic is really important for the park example, since we don't know how many visitors come to the park each day, and when the park gets busy, it suddenly gets busy. So we don't need to plan for any of that. It will scale to meet the demands of our visitors. So as it says here, we just need to configure this delivery stream and then start sending the data into the service. Now Kinesis, there's a lot to learn on this service. It's extremely powerful, and if you're interested in finding out more, there's a link here that explains a lot about how the service works. But today gives you a taster of how we can use this. So let's get started with the step-by-step instructions. And first of all, we want to go to the AWS Management Console, which I'm logged in here. And then we'll go to Kinesis, so I can search here. You can also get to that from the services drop-down. And that will take us to the Kinesis console. Now, for the first time you've ever used this, you'll see this splash screen indicating a getting started panel. If you don't see that, it's because you've used it before, but you can get to the same way, but it gets to the same place by clicking on delivery streams just on the left here. So let's choose getting started and then choose create delivery stream. So I want to make sure we've got Kinesis Data Firehose and create delivery stream. So for a delivery stream name, we're going to use theme park streaming data. So if you type that in, just make sure you put the dashes in as well, but I'll cut and paste to make sure it's identical. And then all of these other settings, we can leave these as default. So you should see that the screen here looks just like the screenshot. So on step 3, now we just choose next on this screen. Okay, step 4. So on the process records page, we're going to leave all of these defaults as well and choose next. So there's nothing to change here. On step 5, for choose a destination, in the destination screen, we're going to leave the Amazon S3 option as the default. And in the S3 destinations panel, we're going to click on create new. So we get this pop-up saying create S3 bucket. This is step 6. So I'm going to create a bucket called theme park data followed by my account ID. So you can find your account ID in the top right hand corner of the AWS Management Console. You can also put your phone number or something else, as long as it's a random number, because S3 bucket names must be unique. So I'm going to enter that. Okay, so for region, make sure this matches the region you've been using for the workshop, and then click on Create S3 Bucket. And the tooltip here says the same thing, that you can find your account ID in the top right, just up there. Great, so that looked like the pop-up we just closed. So we're back in the destination page here, and now we just choose next. Now on this page here, the buffer conditions, this is step 8. By default, this sets a buffer of 5 megabytes. And what that means is that it will receive 5 megabytes of data before the data is written to S3. Or it can use an interval of 300 seconds. And so there's a balance here in terms of number of objects created and latency. So if you have a very, very, very busy system, you might want to increase this number to something higher so you have fewer S3 objects. But if you have less data coming into your stream, then if this number is higher, then you might hit the interval first. So you might have a lag of up to 300 seconds in this case. So really setting these two values depends on your workload. In this case, we're going to change the buffer size to 10 megabytes because we're producing quite a lot of data here. And we'll leave the buffer interval to be the same as 300 seconds. And then scroll down to the permissions section, just at the bottom there, and make sure that the default is selected. Choose create or update an IAM role, and it gives you the name of the role there. And we want to make a note of the role name, so I'm going to open up a text editor and just copy this value down. We'll need that in just a few minutes. Okay, so that looks the same way as the screenshot, so let's click on next. So on the review page, we're going to review, this is step 10, we're going to review all of these settings against the screenshot. So we have theme park streaming data, that's correct. We've got this S3 bucket with our unique ID, account number, phone number, something unique to you. And we've set the buffer to 10 megabytes, and we've got the IAM role configured there. So that's looking good. So we'll click on Create Delivery Stream. Okay, so that now takes just a couple of minutes, and so we want to make sure we wait until this stream is active. It typically takes about 2 minutes just to complete this step. So while we're waiting, it's a good time to talk about streaming data in general. So if you think about streaming data, it's different to regular data you would put into S3 or DynamoDB or a relational database. You know, those types of data are finite, and find there is a file or a piece of a record of data with a certain length, whereas streaming data is essentially unbounded. It's like the video data you get when watching streaming videos, and so you're going to have a continuous flow of this data pretty much continuously once you turn the application on. So Kinesis is great for every time you have an application workload where you have any type of data like that, where it's just a continuous flow from devices or other applications just that are out in the public. Okay, so that now is ready, and you'll see when it's ready, you've got a success message that appears at the top of the screen, just like the screenshot. Great, so the next step is to deploy the simulator. So we'll click on Next to go to the next part. So as we mentioned earlier, we don't actually have a theme park, sadly, but we do have a simulator. And so this will be simulating tens of thousands of visitors coming from all over the country to go to this park. And it uses Faker.js. We'll go through some of the code to show how this works, but it creates fake profiles for our visitors and arbitrarily sends them to different rides at different times where they'll be rating those rides. So this does produce quite a lot of data, around 300 megabytes on average, and it takes about 5 minutes to run. During that 5 minutes, we'll have a quick look at some of the code. And it's going to average about 1,000 transactions per second when it's running, so we get a fair amount of load out of this simulator. So what we're going to do now is just have a look at this JSON object. This is a typical piece of data that one of these wristbands generates when it's sending data onto Kinesis. So you'll see this is the latitude and longitude of the visitor, the arrival time, various timestamps, and so forth. So let's move on to deploying the simulator in the step-by-step instructions. So the first thing we're going to do is go to the Cloud9 instance. I've got this open in a separate tab. If you've closed the tab, don't worry, just go to Cloud9 in the drop-down and it'll still be running. So I'll switch over to this, and I'll close this. This is from our previous sessions. We don't need any of that now. And I'll clear all of this down. So in the terminal, let's go to step 2 and first change the directory to the park stats directory to make sure we're in the same place. And now in step 3, we want to set the delivery stream ARN to what we've just deployed in the console. So I'll show you what this looks like. Before we run the entire command, we'll just run this CLI command, and you'll see this is what the ARN looks like. Now running the entire command just sets it as an environment variable. And then if we echo that environment variable, you'll see that it's exactly the same. So in step 4, we're going to build and deploy the SAM application. And the SAM application is the simulator. So we've done this a few times in previous modules. The first step is to SAM build. That runs the package.json file in the repository, so it fetches any dependencies for the application. And then we package the application, and so that bundles everything together in a zip file and sends it up to the S3 deployment bucket that we defined in step 1 or in module 1. And then in the very last step is to deploy the deployment package. And so that then gets CloudFormation to deploy the simulator. Now a few times we've watched this happen. You can see this going through the console. You can also see this in CloudFormation. So if you want to have a look at what that looks like, I'll switch over to CloudFormation. This isn't in the instructions, but I think it's kind of interesting. And you'll see that we've got this theme park simulator running in progress. So anything that's going on, you can see in the events here. So that just matches what you would otherwise see in the terminal, which is just over here. So the theme park simulator has now been deployed to the Lambda service. So the next step is to get the name of the deployed Lambda function. We can use the Lambda CLI function here to list all the functions in our account, and then just grep for this term for theme park simulator, and then grep for function name. So that returns this name of the function we've just deployed. So I'm going to copy that name to the clipboard as it says in step 6. Make sure you exclude the quotes when you copy this. And then we're going to invoke this Lambda function. So AWS Lambda invoke function name. We enter that function name. Then any output from the file will go into this file called output.txt. Now this takes about 5 minutes to run. So once you start running this, don't be surprised if the terminal doesn't respond immediately. It's going to take a few minutes. And what it's going through now is the simulation of all of these visitors. Now we can look at that simulation code. If we just go back to Park Stats over here and the simulator folder and go to SAM app. This was the template that we just deployed. So what this does is it takes a stream name, which is the Kinesis stream that we deployed manually in the console. And then this is the Lambda function. And it's running a Node.js 12 runtime using 3008 megabytes of RAM. And we pass in the stream name as a reference as an environment variable. And then we make sure that it has IAM access to Kinesis to be able to put records into the Kinesis stream. Remember, you always want your Lambda functions to have as little permission as possible, the principle of least privilege. So whatever they need to get the job done and nothing more. And Sam can really help you define those access rules so that you're not accidentally over-permissioning your functions. Now the code for this simulator is in this function, and this isn't part of the workshop, but I'll show you a little bit here as well. So what you'll see here is this is a Lambda handler, but it's just a wrapper for calling this code in simulation.js. And you can play with these constants here. So this simulator sets the number of hours the park is open, simulates the maximum number of people in the park, and you can change that to something higher if you prefer, and the number of actions per minute, and also a delay between rides. We don't have visitors accidentally just going onto a different ride every minute. So there's some constants that try to make the simulator make a little bit more sense, and it sets opening hours and so forth. But when you go through this, you'll see this is essentially a loop that creates a lot of traffic for our Kinesis stream. Now, while this is happening, what you'll see if we move on to step 7, this is going to take 4 to 5 minutes to complete. So we can actually keep going without waiting for it to complete. So looking at observing the output in S3, moving on to these step-by-step instructions. First of all, we need to go to the S3 console. So I'll switch to that. I was in CloudFormation over here, but I can switch to S3. You can do this from any management console page. I have quite a few buckets, so I'm going to just filter by the theme park ones. And what we'll see in here is this is the theme park data bucket that we created. So in step 2, we're looking for that bucket. Your number will be slightly different. It'll be your account number or your phone number, or whatever you selected as your unique identifier. So when we select this, you'll see in there's a folder. We just drill into the date. And within that folder, you'll see that we've now got 71 objects of 10 megabytes each. And as you refresh, you'll start to see there's more and more of these arriving all the time. So what's actually happening here is the simulator is creating a fair amount of data, and Kinesis is picking all of this up. And when it hits that 10 megabyte buffer that we defined, it then puts it all together and then stores it in this S3 bucket. So over the course of the simulation, you'll see you get quite a few objects that start to appear. We're up to 84 currently. So that was step 3, going through the year, month, day, hour folders until you reach the subfolder. Now in a real production application, this separation of data into these folders is actually very useful. It can help you then locating data if you want to replay things, or you need to be able to find out if there's a system outage or a problem and you want to drill into the data to find out what caused the issue. So we'll almost be done here. We're at 99 objects there, and if I switch back to this, it's still running currently. So yeah, step 4 in this, we can keep pressing F refresh, but you'll start to see all of these new objects arriving. Now at the very end of the simulation, you'll see this JSON response, this 200 code, indicating the simulation has finished successfully. And that should be coming any moment for us now. So we've got the data, and in real life, you could have this continuously being produced and being put into S3. We wouldn't need to wait for the data to stop because it's a streaming application and the data never stops. So the next step is to go to Quicksight, and we're going to do that next. This shows the pricing grid here. We're just going to select the standard option there, as it says in step 3 here. And at the bottom of the screen, just click on Continue. So in the next page of the sign-up process, that's step 4, just double check the region is the same as the region you've been using throughout the course. Now for your account number, we're going to put in theme park admin. You can use your AWS account number, which, as the info box says, you can find in the top right of a regular console screen like up here. Or you can just use a unique number such as your phone number, something that, so you've got a unique account number. I'm going to just use that sequence of numbers. And then I'll put in my email address. Then uncheck any checkboxes. So when you uncheck this one, this causes a pop-up to appear. So that's normal. So create a pop-up, and you should get a display that looks very similar to this. In step 5, we want to just unselect anything that's been pre-selected, and then at the bottom, we're looking for this theme park data bucket that we created earlier with this code. So just check that box. And then you'll see this looks about the same, and then click Finish. Then finally, as step 6 says, choose Finish again. That's at the bottom of this original screen, just here. So this goes about creating the account. It just takes a few seconds to create this, and then you'll get taken to the landing page. So, if you're new to Quicksight, you might get some pop-ups for splash screens showing new features and so forth. Just go through those or read them and close them down so you get to the regular dashboard. So there we go, with the confirmation that we've created the Quicksight account. And now we'll just go to that console. It just takes a few seconds to load, and that is your starting point. Okay, the next step is to configure Quicksight. So in the step-by-step instructions, in step 1, select datasets on the left here, and then choose New Dataset. In step 2, choose S3. You can choose a whole range of different data sources for Quicksight, but just for this workshop we're using S3. And now in the next step, we want to open a text editor on your local machine. And the reason for this is we need to create a manifest file for this particular pop-up. So I'll open a text editor. And what I'm going to do is paste the contents of this into my text editor. So I'm just using Notepad here, but you can use any editor you prefer. Now that bucket name that we noted down in the previous section, we need to paste that into this section here that says enter your bucket name. So just paste that in there. And then save this file so that we're suggesting you call it ctemp manifest.json. But you can really call it anything you like as long as you can find the file. So now we can close this down. And now back on this S3 data source pop-up in step 5, enter theme park data for the data source name, then check the upload radio button, choose that file loader icon, and paste in the manifest that we just created, the manifest file. So your screen should look like this, just like this, and then we're going to click on Connect. So you might occasionally get this message. I've been using this before, so that's why I'm seeing that, but you will otherwise see a message saying that you have the correct amount of spice capacity available. Spice is the storage capacity used by Quicksight. So now when that's finished, what's important here is click on Edit and Preview. Don't click Visualize. Click this icon or this button on the left-hand side. So the first thing we want to do is prepare the data for Quicksight. So what it's done is it's looked at the data in our S3 bucket and determined these are the fields or the attributes it's finding in the JSON data that's being stored there. The only thing we want to do is we want to change the latitude and longitude to be geographic data types. So how to do that is you hover over, in this case, latitude in step 1. Hover over this ellipsis icon and then select that. Then change data type and select latitude. And by doing that, we're changing it from a number to a special data type that indicates it's geographic data. In step 2, we're doing exactly the same thing, but for the longitude field just here, click on the ellipsis, change data type, and then select longitude. Great, so that's now correctly identified this data. And the data types are shown by these icons on the left in these fields. Next, we're going to use a calculated field. So we can do this if we take the data and want to add some sort of value that's derived from the data that's being provided, but it's not already there. So to do that, in step 3, we're going to choose this Add Calculated Field button. So for the name, we're calling this Minutes in Park. So that's the name just there. If you click on that field, you can edit that and paste that value in. And this is the formula box. So you can paste in this formula. And you'll see what it's doing is it's calculating the difference between the visitor arrival time and the timestamp of the message in minutes. So it's working out how many minutes into the park this event happened. Finally, choose Save up here. That was the screen we just saw. Then once you get to back to this screen, in step 4, choose Save and Visualize, which is this button just there. Okay, so we're ready now to create some analyses. So in this screen, click on the Quicksight logo in the top left, just so we're all starting in the same place. I'm going to delete this because I had that from before. So that's the screen you should see. And the first thing we're going to do is click on Create or click on New Analysis in step 1. This takes you to this screen. In Datasets, choose Theme Park Data. That's the one we just imported. And in this step 3, you'll see that we've got nearly 2 million rows of data there, about half a gig. That's probably around the amount of data you should see if you run the same settings in the simulator. So we're pulling in these 2 million rows, and we're going to create an analysis just in the bottom right there. Okay, and it's imported that data. Now the most important thing with Quicksight really to be able to navigate it fairly quickly is just to know what the different parts of the screen are. So we've given a bit of a guide in step 4, but this panel on the left is a menu bar where you're going to find most of the major parts of the functionality for building analyses. Then section 2 here is this fields list. That's unique to whatever data set you're pulling in at any given point in time. Section 3 are visualization types, different types of graph, map, chart, and so forth. Field wells appear at the top. We haven't seen any just yet, but you'll see those in just a second. And then the worksheet on the right contains any visualizations that you're building. So just know those 5 different areas when you're navigating around to build these visualizations. Okay, so for the remainder of this session, we're going to look at 5 different visualizations to answer different questions raised by the park's business. Now we've prepared the data and pulled that in. So we want to know the average length of park visitor by age. So we'll go to those instructions. So this one is going to use events in the park to work out the average length of a visitor. It's going to look at exit park events to work that out. So here are the step-by-step instructions. First, we're going to click Add in the top menu bar and then click on Add Visual. Next, we'll go to the Analysis menu bar and click on Filter, which is just here. Then we'll click on create one. In step 3, I'm choosing event from this list. I click event, click this just here, and then I want to deselect what's been selected and just select the exit type there. Then choose apply and close. That's the whole of step 3 just there. So you'll see now we've got one filter on event. On step 4, I'll choose visualize from this menu bar. And in the visualization types, which are at the bottom, in step 5, I'm choosing the horizontal bar chart. That's that one just there. So now step 6, we want to click the Field Wells panel to open this section. This is already open for me. It might be open for you as well. Step 7, drag the visitor age, just that field, to the y-axis. And then step 8, drag minutes in park, that's that calculated field we created, to the values, or the value field well. I'm selecting the drop down here. It's selected count, but we want to change the aggregation to average. We want the average minutes in park. So I'll just click on here and click on average. Now, your data will look probably just a little bit different because there's some randomization in the simulator, but what we'll see here now is we've got a visualization showing the average minutes in park by age. So 500 minutes for 15-year-olds, 400 for 20-year-olds, and so on and so forth. Great, so that's that finished visualization. Let's go to the next one. So now we want to know, in number 2, where are the visitors from? Okay, great. So we're using this. We're going to use the latitude and longitude data in the entry park events to show the home location of visitors on the map. So to do this, click on Add in the drop-down, and then choose Add Visual. Click on Filter in the analysis bar, and then choose Create One. And step 3, choose Event from the list. Then click on the event. It's going to load those values. You really just want the entry value, so just deselect the others and just click on Entry. And then choose Apply, and then close. In step 4, click on the Visualize option in the analysis bar, and then choose Points on Map in the visualization types. And that one's just that one there. There's lots of different types there. In step 6, you may need to click on Field Wells to open it. It's open for me automatically, so I can go straight to step 7, where I'm dragging the latitude and longitude from the field list to the geospatial box there. So drag that one, and then that one. I can drag them both together. So highlighted them, I drag them both together to appear. And then we can change the title to Insights of where my visitor is from. Then I can zoom in, but that shows me then where on the map all my visitors are coming from in the park today. You'll see that on this other time it was run, it's more scattered. This time everybody's around Washington. So that's the second visualization. Okay, let's go back to visualization. So now the third question we want to answer is arrival time by visitor age. So each of these follows a similar process. We'll go to those instructions, scroll down to step by step, click on the Add drop-down here, and then Add Visual, step 1. Step 2, click on Filter, and then Create One. Click on Event in step 3, then click that event, and we're changing this to the entry event. We're only interested in entries for this. And then Apply and close. Step 4, click on Visualize. For this, we're choosing Line Chart. So that's that icon just there. Field wells again are open for me, so I can skip on to the next step where I drag the arrival time, which is this one here, into the well. So that's in the x-axis. And then click on the drop-down arrow next to the arrival time field and select the aggregate submenu. And we're changing that from day to minute. So just select that option there. Step 9, drag the visitor age from the fields list to the color box in the field wells. So we're going visitor age is this one here, pulling that over to the color box. And we can change the name of this visualization using that title. Just check that title and then paste that in just there. And then what you can see there is this is the arrival time by visitor age. The ages are shown on the right hand side and the times are shown across the bottom. And you can see that's fairly similar to this. If you've got a full screen window, you might be able to see this a little bit more clearly. So that's the third visualization. So let's click back to the visualization list and look at the fourth one. We want to look at ride rating by popularity. So this time we're going to use a tree map, and that shows the size of each box that represents the total number of riders per ride, where the color coding indicates the average rating. So if you saw in the JSON payload, there's a rating from 1 to 5 for visitors, so it'll be using that. So in step 1, we click on Add, and then Add Visual. Step 2, click on Filter, and then Create One. Then we'll choose Event. And this time we're choosing, click on Event, we're going to choose Ride. So uncheck those, click on Ride, and then Apply and Close. Now we click on Visualize in the menu bar, and then we'll choose Tree Map, which is this icon just here. Step 6, open field wells. That again is open for me. So step 7, I'm dragging the ride ID from the field list to the group by box in the field well, which is just there. Step 8, I'm dragging visitor ID from the field list, which is this value, to the size box in the field well. And then finally I'll drag the rating from the fields list, it's this one here, to the color field well. And we want to change the aggregation from sum, just there, we just click that, changing that to average. So just open that aggregation menu and then select average to complete step 10. Finally, we'll change the title. So I'll just click this and we'll give it a real title. So there it is. So now you can see each ride and its popularity by color and the number of times people have been on the rides based upon the size of the boxes. It's similar to the example just here. It'll vary slightly because of the randomization. Ride number 5 has a rating of 3 in this case. But okay, so that's that visualization. So the next question, finally, number 5, we're looking at how many rides there are today. So this is going to look at the total number of rides taken in the entire park. Now to do this, we go to the Add menu at the top, step 1, and choose Add Visual. Step 2, I click Filter, and then Create One, and select Event in step 3. Click on the event, and then just deselect those, and we're selecting Ride, and then just finishing step 3 by clicking Apply, and then Close. Step 4, click on Visualization, and then we're looking for KPI. as the type. So you'll see KPI as this icon just here. Click on the field panels. So again, that's open for me in step 6. I'm going to drag the ride ID from the fields list to the value box just there. And then we're going to give this a title. I'll just cut and paste the title from there, checking that to there. So that just gives us a KPI box indicating how many rides have been taken in total today. So 781,000 in the screenshot and over 1 million just here. Okay, so that is the end of that section. But what you can do, you can scroll down to the main section here and you'll find a section called Advanced Challenges that offers some challenges that you can try to see and get your handle around Quicksight. I think a lot of these dashboards are easier to understand if you have some challenges where you can play with the data. So 3 different scenarios. One is making the park free on your birthday. Management wants to know what the cost of this program would be. The second is around staffing the turnstile based around the capacity in the park and the number of times people arrive and what time of day. So you can make recommendations around park staffing. And then the third is around determining which rides are not performing, which rides are the least popular, and see if those ratings vary significantly by age group, and also see if the uptime may be impacting the problems with that popularity. So have a go with Quicksight, see if you can work out those 3 challenges. So that brings us to the end of this module. So this module, we set up a Kinesis Firehose to ingest data from the park and see what park visitors had on their wristbands and store that data in a dedicated S3 bucket. We then launched a simulator to generate all that test data for analysis and streamed the data into Firehose. And then we set up Quicksight to perform business intelligence analytics on the sample data. And we ran through some example visualizations to give you a sense of how that works. So thanks very much for joining me today on this streaming data and park statistics module of Innovator Island. That concludes today's session. So tomorrow we'll be looking at the event messaging part of the course. So I hope you can join me for that. If you're continuing straight on this video, then just leave all the windows open and we'll pick up where we left off. Otherwise, thanks very much for joining me, and I'll see you next time.